In the spring of 1944, the U-boat pen at Saint-Nazaire stood as a terrifying monument to Nazi engineering. A colossal, gray concrete cathedral rising from the French coast. Its roof was a staggering 20 feet thick, a design calculated to laugh off the heaviest bombs in the Allied arsenal. Inside this bomb-proof fortress, beneath the shuddering concussions of futile air raids, the Kriegsmarine calmly serviced and repaired its deadly U-boats in protected dry docks. It was the pinnacle of defensive arrogance, a symbol of a regime that believed it could defy the laws of physics and the combined might of the Allied air forces through sheer mass of concrete and steel. These bunkers were considered functionally indestructible. Yet, within weeks, a shocking and humiliating vulnerability was exposed. Not at one location, but across 14 of these impregnable underground facilities along the French coast, critical operations ground to a halt. The cause was not a revolutionary new bomb. According to frustrated German damage reports, the culprit was a cascade of routine, almost banal, maintenance failures, a series of collapsed sewage outlets and ruptured drainage pipes. In reality, it was a silent, coordinated campaign of sabotage. The attackers wielded wrenches, not explosives. Their target was not the fortress itself, but the plumbing that served it. By sabotaging these critical outlets, they turned the bunker's own necessary systems against them, allowing millions of gallons of seawater to pour back in. Saltwater flooded generator rooms, shorted intricate electrical grids, and drowned workshops, crippling the U-boat repair network. The Nazis had built fortresses to defy the skies, but they had catastrophically neglected the ground and the water beneath their feet. They were defeated not by a superior weapon, but by a superior understanding of their own infrastructure's hidden weaknesses. But how did a handful of saboteurs, armed with little more than technical knowledge, cripple some of the most heavily defended structures in Europe? By 1944, the Nazi regime had become obsessed with concrete and steel. Its Festung Europa doctrine demanded not just fortifications, but monumental, bomb-proof citadels. At the forefront was Organization Todt, a massive construction armada employing hundreds of thousands, including a horrific number of forced laborers, whose sole purpose was to pour an empire's worth of resources into the ground. The statistics are staggering. According to Albert Speer's own memoirs, these projects consumed more concrete than had been used in all of pre-war Germany. The crown jewels were the U-boat pens, colossal reinforced concrete shelters like those at Saint-Nazaire, Lorient, and Brest, alongside monstrous production facilities like the Valentine Submarine Factory, a structure containing over 1.2 million cubic meters of concrete. They were cathedrals to a defensive, paranoid mindset. Strategically, these bunkers were the unsinkable linchpins of Grand Admiral Donat's U-boat war. As the Kriegsmarine war diaries make clear, the French Atlantic pens provided the secure havens where the feared wolfpacks could rearm, refuel, and undergo critical repairs, safe from the relentless Allied air patrols. Their continuous operation was essential to strangling Britain's lifeline. This strategic necessity bred a profound technological arrogance. German engineers, believing in the absolute supremacy of mass, designed roofs up to 28 feet thick, calculated to withstand direct hits from the Allies' soon-to-be-deployed Tallboy earthquake bombs. Propaganda films showed Hitler confidently inspecting models, and the pens were inaugurated as triumphs of Aryan ingenuity, physical manifestations of an ostensibly thousand-year Reich, impervious to enemy action. They represented the peak of documented German faith in monumental defensive engineering, a belief that sheer bulk could defy any attack from above. This was the impregnable reality that Allied planners faced. Every conventional approach seemed futile against these concrete mountains. But as the Allies pounded these fortresses from above with ever larger bombs to little effect, a different kind of warfare was being planned in London offices and Breton farmhouses. Declassified SOE, Special Operations Executive sabotage manuals and resistance intelligence reports reveal a fundamental counterintuitive truth. Every giant has an Achilles heel, and it's usually buried in the mundane, unseen support systems, the plumbing. For Allied air commanders, the U-boat pens presented a demoralizing equation of diminishing returns. The great strategic weapon of the war, heavy bomber formations, was failing. RAF Bomber Command and the USAF's 8th Air Force launched mission after mission against the pens at Lorient, Saint-Nazaire, and Brest. The official histories record the grim results. Aircraft shot down by dense flak in the hundreds, while post-raid reconnaissance photos showed only superficial scarring on the gargantuan concrete roofs. As one bomber command assessment on Linton concluded with stark honesty, the structures were virtually immune to level bombing. The concrete was simply too thick, the design too robust. The Allies were bleeding air creeds for no strategic gain. This created a profound strategic crisis. Protected within these invulnerable shelters, U-boats continued to sortie into the Atlantic, threatening to sever the Allied lifeline. Simultaneously, new bunkers for Hitler's V-1 flying bombs and V-2 rockets were nearing completion, promising a terror campaign against London that would be launched from similar, indestructible fortresses. A new method was desperately needed, one that didn't require penetrating 20 feet of reinforced concrete from 20,000 feet, but could strike from within the structure's own ecosystem. Allied planners, therefore, had to redefine the problem. The challenge was not how to destroy the bunker's shell, but how to disable the self-contained world inside. Declassified intelligence analyses zeroed in on the facility's life support systems, electrical power, ventilation, and, most critically, water management. Every bunker, especially those built below sea level or on coastlines, relied on a complex network of pumps and drainage pipes to keep the surrounding ocean at bay. Disrupting these systems on a massive scale, flooding the fortress with its own defensive moat, would cripple operations as effectively as a direct bomb hit on the dry dock. This was the moment of strategic pivot, from documented Allied technological impotence against brute force construction to an emerging doctrine of asymmetric systemic sabotage. The solution came not from physicists, but from plumbers and civil engineers recruited by the SOE. Their target analysis, found in mission briefings, was brutally simple. Flood them. Let the sea do the work. To defeat the fortress, the Allies targeted its veins and arteries. Using captured and clandestinely obtained German blueprints, SOE engineers analyzed the U-boat pen not as a monolithic block, but as a living organism. Its lifeblood was water. Massive intake pipes drew seawater for cooling generators and filling dry docks. Even more critical were the vast outflow and sewage pipes, some several feet in diameter, that drained wastewater and pumped out bilges, expelling it all back into the harbor. Sophisticated pumping stations maintained the delicate balance, keeping the operational levels dry. This was the complex's hidden circulatory system, and its components were far more vulnerable than the concrete shell. The sabotage method was a masterpiece of minimal force for maximum effect. As outlined in SOE field pamphlets, the goal was not a spectacular explosion, but a precise, disguised incision. A small, shaped charge or an application of an industrial cutting tool to a critical joint or valve housing on a main outflow pipe, ideally performed at low tide. The damage would be made to look like natural structural failure, corrosion, ground settlement, or a manufacturing flaw. The trap was then set. When the tide rose, or when German technicians activated the pumps to drain a dock, the ocean would rush back through the ruptured conduit. Seawater would flood into the internal drainage network, back up, and cascade into the lowest levels of the complex: the generator halls, electrical switchgear rooms, and machine workshops. As one SOE manual noted, this attacked the nervous system, not the limb. Executing this required not brawn, but insider knowledge. Saboteurs were often sympathetic French workers employed by Organisation Todt, or resistance cells who had spent months meticulously observing the routines of German maintenance crews and mapping the labyrinth of external pipework and access hatches. Their intelligence was golden. This was documented Allied technical cunning, exploiting a profound German blind spot. The Nazis had over-engineered the shell to an absurd degree but, according to post-capture technical surveys, often used standard, even inferior, fittings and pumps for the utilitarian support systems they considered beneath their engineering pride. They had fortified the skull but neglected the carotid artery. The force multiplier effect was devastating. One successful hydraulic sabotage could paralyze a pen for weeks or even months. Repairing submerged high-voltage equipment and massive saltwater-corrupted pumps was a logistical nightmare, requiring the near-impossible task of draining the flooded chambers, all under the constant threat of Allied air attacks that would target any repair efforts. With the plan set, the saboteurs moved. German naval security logs from ports like Brest and La Pallice, later captured, show a rising tide of accidental infrastructure failures in the spring of 1944 that coincided mysteriously with high tides. The operation was a silent war fought against the clock and the tide. For days, resistance observers, often posing as idle fishermen or dockworkers, had charted the rhythms of the centuries. They noted the massive, barnacle-encrusted outflow pipe where it disappeared into the harbor's stone quay, a critical juncture far less guarded than the bunker's main gates. They consulted tide tables, waiting for the perfect conjunction. A moonless, rainy night when German patrols would be huddled against the weather, and a low tide that would expose the target and, crucially, minimize the initial backflow. The margin for error was zero. On the chosen night, a team of 2 or 3 moved like shadows through the downpour. Their tools were minimal. A waterproof pack containing a shaped plastic explosive charge or a heavy-duty hydraulic cutter. Reaching the pipe, they worked with frantic, focused speed. In one scenario, they molded the charge around a welded seam. In another, they clamped the cutter's jaws onto the iron. A muffled crump or the violent, metallic scream of shearing metal was swallowed by the howling wind and crashing waves. For a moment, nothing. Then, a violent geyser of stagnant water and debris erupted from the rupture as internal pressure released, followed by a new, more ominous sound. The deep-throated, growing roar of the sea itself being sucked backward into the broken line. Their mission complete, the saboteurs vanished into the labyrinth of wet streets and blacked-out alleys, leaving behind not the signature of an attack, but the apparent scene of a catastrophic industrial accident. The first German guards to arrive, summoned by the unnatural noise, saw only a burst pipe, a maintenance headache, not a battle. Their reports would log a structural or material failure, likely due to corrosion or ground stress. This was the precise, documented vulnerability of the act. The saboteurs were exposed for mere minutes. But their success hinged on the verified German perception of such events as mundane, not malicious. The real, creeping disaster was just beginning. It would take hours to manifest. As the tide rose, the unstoppable hydraulic force of the Atlantic Ocean began pouring into the breached conduit. Saltwater first filled the underground drainage channels, then seeped into the bilges of the pen's lower decks. The flood was silent, patient, and inexorable. Dawn would reveal the accident. But by midday, as frantic reports reached the harbor master, the truth became terrifyingly clear. Damage control reports from the Kriegsmarine for the affected bunkers detail a disaster no bomb could have caused. Inside the fortress, the first sign was a trickle, then a stream where no water should be. A petty officer in the Maschinenraum, the engine room, shouted the alarm, "Wasser im Maschinenraum." Technicians initially blamed a burst internal pipe. They switched the powerful drainage pumps to maximum. But the water, cold, oily, and mixed with sewage, continued to rise. Then, with a shower of blue sparks and the acrid stench of ozone, the first electrical panel shorted out. Lights flickered and died. The hum of ventilation fans sputtered into silence. The water wasn't coming from within the walls. It was surging up from below, through floor drains, cable conduits, and pipe trenches, the very veins of the complex. As captured German damage reports describe, it was an uncontrollable flooding via ruptured main outflow conduit. Panic mutated into a desperate, losing battle. Crews attempted to dog down watertight doors, but the flood ignored these vertical barriers, rising from the deck. In dry docks, the rising water threatened to float U-boats off their stabilizing blocks, risking catastrophic damage to the submarine's hulls. Workshops containing delicate machine tools were abandoned as the black, salty tide swallowed benches and lathes. The garrison was forced into a frantic retreat upwards, evacuating the bunker's vital lower depths, the power stations, fuel pump rooms, and armament stores. Within hours, the pinnacle of defensive engineering was transformed into a stagnant, toxic, and lightless trap. Radio equipment drowned, cutting the facility off. The only sounds were the roar of inrushing water, shouted orders, and the futile clanging of hammers on sealed access hatches. The strategic impact was absolute. A U-boat pen was rendered paralyzed, flooded cavern. Submarines could not be repaired, rearmed, or refueled. A V-weapon preparation bunker found its fuel mixing pools contaminated and electrical guidance workshops destroyed. The reported disabling of 14 such facilities, whether through this exact method or a combination of similar sabotage, represented a massive, undocumented degradation of German capability along the Atlantic Wall at a critical moment. The D-Day landings were months away. Every delayed U-boat sortie and every V-rocket that couldn't be assembled mattered. The psychological blow was equally severe. The demoralizing realization dawned that their impregnable fortress had been defeated not by a superior bomb, but by a trick, an exploitation of a mundane oversight. It bred deep paranoia. Was it sabotage or incompetence? Every subsequent pipe failure, every pump malfunction would be viewed with suspicion. Furthermore, it triggered a massive diversion of resources. Thousands of man-hours from skilled organization-towed engineers and German sailors were wasted not on building new weapons, but on the nightmare of emergency pumping operations, draining, and the near-impossible task of repairing saltwater-corrupted electrical systems. It was a documented case of German operational paralysis and humiliating technical defeat, achieved by resistance ingenuity with minimal resources. The immediate tactical win was immense. But as Allied intelligence analysts pored over aerial photos showing bunkers surrounded by water or spewing pump hoses, they realized the campaign had an even broader, more corrosive effect. The flooding did more than disable bunkers. It triggered a cascading crisis that drained the German war machine at a critical moment. The initial sabotage was a pinprick. The enemy's reaction was a self-inflicted hemorrhage. Organization Todt, already stretched thin fortifying the Atlantic Wall and constructing V-weapon sites, was forced into a massive, unplanned diversion. Precious heavy-duty pumps, generator sets, and teams of specialized engineers, resources desperately needed elsewhere, were rerouted for weeks, even months, to the thankless Sisyphean task of draining and repairing the flooded complexes. It was a textbook case of asymmetric warfare. A handful of saboteurs with simple tools could force a thousand-fold greater expenditure from their enemy. Simultaneously, a climate of corrosive paranoia took root. As Sicherheitsdienst, SD, security reports from the period note, every subsequent pipe failure or pump breakdown was now viewed as potential sabotage. German troops increasingly distrusted the essential French workforce, leading to arbitrary arrests, stringent new security checks, and a collapse of efficiency. The resistance had not only broken pipes, they had shattered trust, turning the occupiers against the very people they relied upon to maintain their fortifications. This resentment further fueled the underground war. Operationally, the impact was direct. The safe havens of the U-boat pens became logistical quagmires. U-boats returning from patrol found their designated ports in chaos, forcing the Kriegsmarine Command to divert them to other, often less equipped facilities. This disrupted the finely tuned scheduling of Wolfpack tactics, increased transit times, and left submarines more vulnerable in less protected harbors. In the post-D-Day context, this dysfunction was magnified. Many of the sabotaged bunkers were in Brittany and Normandy. Their impaired condition hampered German naval responses to the invasion fleet and complicated the retreat and resupply of ground forces now trapped in the Allied onslaught. The campaign had morphed from a tactical nuisance into a verified strategic hindrance, amplifying the chaos of Germany's crumbling Western Front. This was the documented German crisis, a logistical nightmare and a security obsession, both triggered and sustained by a simple, elegant attack on their infrastructure. While the Germans bailed out their fortresses, the architects of the flood campaign were already being studied. The principles they used would not be forgotten in the conflicts to come. The flooding campaign's success delivered a powerful, documented lesson to Allied strategists. Precision sabotage could succeed where indiscriminate bombing had catastrophically failed. Internal SOE and OSS after-action reviews contrasted the minimal cost of a few wrenches and explosives with the staggering loss of hundreds of aircrew and aircraft in futile raids on the same targets. This validated the model of targeted, intelligence-led clandestine warfare, proving that understanding an enemy's technical systems was as important as matching his firepower. The economic equation was irresistible. This lesson was institutionalized. In the early Cold War, veterans of these World War II operations brought their hard-won doctrine into new agencies and special forces units. The core principle, attack the system, not just the structure, became foundational. Plans for sabotaging Soviet infrastructure in the event of a European war, targeting rail hubs, power grids, and communications nodes, were direct descendants of the logic that had flooded the U-boat pens. It cemented infrastructure vulnerability as a cornerstone of modern unconventional warfare doctrine, a legacy that endures in special forces missions to this day. Yet, the story itself remains shrouded in historical obscurity. Unlike the D-Day beaches or the bomber streams over Berlin, these operations left no dramatic newsreel footage or grand memorials. Their success is buried in the dry language of German engineering damage reports and in the silent, lasting corrosion within the bunker's concrete bones. The saboteurs themselves are the ultimate testament to the anonymous, technical resistance. Most have no names in our histories. Some were undoubtedly caught by the Gestapo or SD, tortured and executed. Others simply returned to their day jobs, their colossal act of warfare known only to a handful of comrades. Their victory was not in holding ground, but in imposing a debilitating, hidden cost. This episode represents a documented Allied refinement of a potent, economical form of warfare, standing in stark contrast to the verified German struggle against an elusive, non-traditional threat that bypassed their strongest defenses entirely. It was a war of plumbers against admirals, and the plumbers had found a fatal pressure point. Historians of technology and warfare now see the flooded bunker not as a quirky anecdote, but as a classic case of systems defeat, a preview of how modern conflicts are won by disabling networks, not just attacking nodes. The story of the flooded bunkers is far more than a tactical footnote. It is a documented early masterpiece in the enduring art of critical infrastructure warfare. Centuries before cyberattacks on power grids or drone strikes on oil refineries, these saboteurs grasped a fundamental principle. To collapse a military capability, you do not need to destroy its strongest point, you need to sever its lifelines. By targeting the water management system, they attacked the bunker's metabolic function. This campaign stands as a clear precursor to modern asymmetric strategy, where a small, intelligent input can trigger a catastrophic systemic failure in a much larger, more powerful adversary. It is also a timeless case study in the power of engineering intelligence. The saboteurs, many of them civilian engineers or skilled tradesmen, won because they understood how the fortress was built. They read its blueprints not as a guide for construction, but as a map for deconstruction. Their war was not fought with rifles over open ground, but with wrenches in the dark, at the intersection of hydraulics and structural weakness. As modern military engineering doctrine notes, the task is often to deny the enemy use of critical facilities, with effects disproportionate to the means employed. This is the exact, quantified victory they achieved. Within the grand narrative of the French resistance, this story elevates it from the realm of brave ambushes and espionage to that of sophisticated technical combat. It showcases a resistance that was not just courageous, but brilliantly competent, a force that could hurt the technologically advanced Wehrmacht in a deeply modern way by mastering the enemy's own technology. It shifts the focus from the Maquis fighter in the hills to the anonymous technician in the dockyard, whose specialized knowledge became a weapon as potent as any partisan submachine gun. The ultimate lesson is one of intellectual triumph over mass. The documented legacy of this campaign is a philosophy of warfare. That victory often goes not to the side that builds the thickest wall, but to the side that best understands the hidden pressures acting upon it. The Nazis invested millions of man-hours and tons of steel in a static, monumental defense, only to see it defeated by a handful of individuals who thought in terms of flows, pressures, and systems. Their fortresses, symbols of permanence, were undone by the most fluid and relentless element on Earth, water, guided by human ingenuity. So what is the ultimate flowing lesson from this story of concrete, pipes, and seawater?